Hey guys, I'm continuing straight on from the previous video. So the next thing we're going to do is just find our axial load, which is given by the compression in steel 1 plus compression in steel 2 plus compression in steel 3 plus the compression in the concrete. So we found all these values from before. So there's steel 1, steel 2, steel 3. So just adding them all up, plus the compression in the concrete, which we found in one of the previous videos, was 595. So subbing that in there, we find that the total axial load in our in our section is 803.7 kilonewtons. The next thing we need to do is find the moment in our section. So what we need to do is see where each of these forces are acting. Now, very simply, I'm going to redraw this nice and big just to show you, but just showing you in perspective to our whole thing. The steel is just going to be acting at its corresponding layer. So I'm just going to where the strain each layer is. So this was compression steel 1, compression steel 2, and compression steel 3. And the compression in the concrete is going to act in the center of the rectangular stress block. So it's going to act around there, compression in the concrete. So because it's rectangular, we know the centroid is just the midpoint. So I've roughly drawn it in the center there. And the last thing we need to do is put in the distance from our plastic centroid, which is what we're going to be taking moments about. So I've redrawn it nice and big. This essentially is what it looks like. So we have the compression in steel 1, compression in steel 2, compression in steel 3. We know that those layers were at 15, 100, and 185. 15, 100, 185 were each of those layers from the top. The distance of our plastic centroid we found in the previous videos was 103.9 from the top. And the compression in our concrete, so that acts at, this distance here was gamma KUD, which we know is gamma D because of this problem we have, that the KUD equals D. So the distance from the top to the compression in the concrete would just be gamma D divided by 2. Okay, so it's just gamma D divided by 2. Now we're going to be taking moments about the plastic center, the plastic centroid. We're going to be taking moments positive anti-clockwise, the sum of the moments positive anti-clockwise. So you can see that steel 1, concrete, and steel 2 are above the plastic centroid and are therefore going anti-clockwise about the plastic centroid, each of those, which means they're going to be positive moments. But the compression in steel 3 is going clockwise about the plastic centroid. So that's actually going to be negative. So positive, 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 negative. So let's deal with the compression in the concrete first. So that one there. So it's going to be 595. I need to work back in newtons. So these are all in kilonewtons. So I'm switching back to newtons now. So it's 595,000 times by its lever arm. So its lever arm will be 103.9 minus the distance of what it acts, which is gamma D on 2. So we found gamma in the previous video to be 0.7. So it's 0.7 by D. D, the depth of the section, we know is 200. So it's times 200 on 2. So that's from the concrete. Now for steel 1, so this layer here, the compression, so the force is 125.5, putting it into newtons, so times 10 to the power of 3. Outside of its lever arm would be 103.9, so that distance there, minus its distance from the top, so minus 15, plus steel layer 2, so 67.9, so 67.9 times 10 to the 3 to get it in newtons, outside of 103.9, so its lever arm, which would be this tiny distance here, which is 103.9 minus the distance from the top, which was 100. Okay, so minus 100. And finally, minusing, because this is acting clockwise, so it's going to be a negative moment. 15.3 kilonewtons is the force, so 15.3 times 10 to the power of 3 outside of its lever arm. Now I'm going to switch it around. I'm going to be going, the distance from there to there is 185 minus 103.9. 185 minus 103.9. What you could have done is you could have done 103.9 minus 185, but that then would have to be positive. So I'm making it negative, and I'm just aware of the fact that it's 185 minus 103.9. Once again, you could have made it plus 15.3 times 10 to the power of 3 outside of 103.9 minus 185, and that just does the same thing. But just be aware that this is going to be a negative moment, okay? Because it's going clockwise. So all I've done essentially is I've found the force and I've multiplied it by its lever arm about the plastic centroid. That's all we're really doing. If you were to work this out, you would get a moment of 30.35 kilonewton meters. Okay guys, so that pretty much sums up the decompression points. Just a quick summary. We found the compression in the concrete. We then had to find all the strains in the steel and convert those to compressions. We then found the axial load just by summing it all up, and then we found the moment about the plastic centroid, and that is how you find the decompression point. It's in 10.6.2.3. Anyway guys, hope that helps, and we'll see you in the next video.